We're looking at simplifying trigonometric expressions in this section here. We have a whole bunch of what are called trigonometric identities. These are a whole bunch of true statements, true relationships between the different trig functions that are known. Okay, so let's take a look at these. These are ones that you're going to want to become very familiar with. Could even, maybe make flashcards for them or something like that, or just kind of have a piece of paper with all these written on them that you have in your pocket that you look at all the time, or take a picture with your phone and look at that picture occasionally, and you just want to become really familiar with these. Some of them, hopefully, you feel like you already know. So reciprocal identities, hopefully we already know cosecant is the reciprocal of sine. Maybe the quotient ones, and so on for secant and cotangent. Hopefully all those we already know. The quotient ones, we might already feel like we know this. So tangent on the unit circle was y over x. Well, sine on the unit circle is y, and cosine in the unit circle is x. So y over x equals y over x. So hopefully we know that. And then, of course, cotangent would be the reciprocal, the x over y. So hopefully this first line, you feel like maybe you already knew all those, or it doesn't seem like much of a stretch. Those we might be pretty comfortable with. Then we have these Pythagorean identities here. Okay, so you might guess where those come from based on the name. If they're Pythagorean, they probably come from the Pythagorean theorem. So let me just quickly show you how we get those, or at least one of them. So if we have a right triangle here, of course, we have the Pythagorean theorem. And so what we do to get these different identities is we could divide through the whole equation by one of the variables. Okay, so if you divide over by a squared, you get one of the identities. Divide over by b squared, you get a different one. Let me show you dividing everywhere by c squared. Right, so if we do that, and then of course a squared over c squared, that's the same thing as a over c squared. And then b squared over c squared, that's the same thing as b over c squared. And then c squared over c squared is 1. Well, a over c, take a look at what that would be in this triangle here. All right, well, a over c, that's opposite over hypotenuse. That would be sine. So we have sine of x squared. And then b over c, well, b would be the adjacent side, adjacent over hypotenuse. That's cosine. And then that equals 1. Okay. And then again, I think we saw this in one of the previous sections. We have, we don't want to have to write these parentheses over and over again. So mathematicians have a nice lazy / efficient way of writing this. We put the squared next to the sign there. Okay. So again, what this means here, if I say sine squared x, what that means is sine of x squared. What we want to keep straight is the difference between if I have sine x squared, if I just wrote it like that with the squared at the end with no parentheses, what that would mean would be that just the x was squared. It would be sine of x squared. Okay? But mathematicians are far too lazy / efficient to write those parentheses over and over again. So we just have these conventions here. So you're going to see sine squared and cosine squared a lot in this chapter. What that means is we're taking the whole trig function. We're taking the whole function and squaring it. Sine squared x means sine of x times sine of x, sine of x squared. Okay, and so we could have these other ones here. You could either divide this equation everywhere by sine squared. If you divide this one everywhere by sine squared, you'll get that one. Divide everywhere by cosine squared, you would get this one. Or you could go back to this right here. Instead of dividing by c, either divide by a or b. Right? So we have these Pythagorean identities, and notice they have to have the squareds here. Sometimes people think, well, if I change it to a cube, will it still be true? Or what if it was just sine plus cosine? Would that still be 1? None of those would work. These are only true if they have the squareds here. If they don't have the squared, it's not going to be true. So you see in some of these guidelines here, if and only if it's squared, are you going to use these Pythagorean identities. There has to be a squared on the function for these identities, these equations to be true. Okay. So then we have these odd and even identities here. We'll try to think if you remember any time that we talked about things being odd and even before. Well, we talked about odd and even functions, right? So where these come from is whether the trig functions are odd or even. So if you take a look, so these are my notes from 4.7, so there's some of the scribbling that we did on there, but hopefully you can still kind of see what I'm going to talk about here. If we look at sine of x, remember an odd function was symmetrical about the origin. Well, that's what sine of x is. Sine is symmetrical about the origin. If you have a negative x, you have the negative y. Opposite x, opposite y. There's this symmetry. If I rotated the sine function 180 degrees about the origin, it would still look the same thing. It would be the same graph. Okay? So sine is an odd function. If you look at cosine, cosine has that symmetry across the y-axis. Opposite x, you still have the same y. Negative x, positive x, you still get the same y value. Cosine's an even function, symmetrical about the y-axis. Okay, so based on what that graphical feature of these functions are, we have these identities, these odd even identities. So both sine and tangent are odd functions, symmetrical about the origin. So if you plug in a negative, you get a negative. So those are probably, if you had to guess, you probably would guess that. The one that you might not, otherwise guess is this one. This one's the kind of weird one where for cosine, if there's a negative x, it doesn't really matter. It just kind of disappears. Cosine of negative x, same thing as cosine of x. Cosine, the negative will just kind of disappear. That's kind of the weird one there. Right? All right, so what we're going to try to do is we're going to have problems like these, and we're going to try to simplify them down using these different relationships, okay? And so I've got some guidelines for you here. Make sure you notice that they're just guidelines. They're not rules. Okay? It's like Pirates of the Caribbean. They're just guidelines, okay? And so these are tips. These are, maybe 90% of the time these will apply, but they're not 100% hard and fast rules. They won't always be true. They're just kind of some general strategies that might be helpful. Okay. So, again, only if it's squared are you going to use the Pythagorean. And then one that we're going to use a lot right here is this second one. A lot of the times we're going to rewrite things in terms of sine and cosine. So based on these identities at the top here, every other trig function can be written in terms of sine and cosine. Cosecant, you write with sine, secant with cosine, tangent, sine and cosine, cotangent, cosine and sine. Every other trig function can be rewritten with just sine and cosine. So let's try that on this one here. So cotangent is cosine over sine. And then cosecant is 1 over sine. We've got that negative x to deal with as well. And so then now that we've got this right here, well, sine of negative x we know is negative sine of x, right? And let's go ahead and write this complex fraction here, this large fraction bar. Let's write that as a division symbol. So we're going to have cosine x over sine x. And then fractions are just division problems. And then 1 over the sine of negative x, let's replace sine of negative x with negative sine x. Okay, so for both sine and tangent, the negative inside can just come outside. So this will be negative sine x. And then, of course, dividing is the same thing as multiplying by the reciprocal. And so we keep and then change flip if you ever were taught that by one of your teachers. All right, and so then now what we've got is we can cancel out this whole trig function here. So sine of x, that whole function can cancel with this whole sine of x function right there. And so then what we've got, well, we'll have a negative 1 here. Cosine x times negative 1, that's just negative cosine x. So there's our answer, okay? That's our goal. Take something a lot more complicated with multiple trig functions, reduce it down, hopefully to only one trig function, something nice and simple like that. Okay? So this one, what you want to do is be able to see these trig functions as just kind of one thing. Like picture this as if you had 1 plus u times 1 minus u. That would be difference of squares, right? That would be 1 minus u squared. Well, this is going to work the same way here. We're going to have 1 minus, and then u squared sine theta squared sine squared theta. Okay, so look at these trig functions as just kind of one thing. Okay? 1 plus something times 1 minus something equals 1 minus that something squared. All right, well, we can keep going further beyond that. We can do better than just 1 minus sine squared. So if you look up here, right now it doesn't look like we have anything for 1 minus sine squared, but use our guidelines. So if something's squared, we try to use our Pythagorean identities. All right, so the one that has sine in it would be this one. So if I know sine squared plus cosine squared is 1, let's see if that tells me anything about 1 minus sine squared. Notice this little note here about including rearranged versions. What we're going to do a lot of times with this is we're not just going to use this statement right here. We're going to say, well, could I rearrange this? Could I move things around to different sides of the equation to get another identity, another statement I could use? Okay, well, if I want 1 minus sine squared, I could do that, right? I could do minus sine squared minus sine squared. If I subtract sine squared from both sides of the equation, what I'll end up getting, I'll show you this here, negative, subtract sine squared from both sides of the equation, and I get cosine squared is 1 minus sine squared. Okay, so that means I can replace 1 minus sine squared with cosine squared. That's a lot simpler. And that is my final answer. That's much more simplified. That's as simple as we get. Okay. How about this one? How about number 3? All right. Again, try to look at these trig functions as just one separate thing here. So, but we've got different ones. So this one, you would look at it as maybe like a u times a v squared minus, and then those are the same, so minus a u. All right. Well, is there anything that we could do with something like that? If you had u times v squared minus u, any kind of algebra that you could do with that? Well, you could factor out the u, right? This has a greatest common factor, a GCF, right? So another guideline here, remember you can factor these things. We're going to do all the different kinds of algebra that we know with these trig functions. Picture a whole trig function, that whole chunk as just a variable that you could work with, that you could factor. And so we're going to factor out that u times v squared minus 1. Okay, so here that means is this sine of x, that whole sine of x, that whole function is our GCF that we're going to factor out. We're going to say sine x, and then when I factor that out, I have cosine squared x, and then make sure you don't forget that minus 1 right here. Okay. All right, well, let's see if we can keep going now. So if we were just using these, there would be nothing else that you could do. But here we've got a squared, right? Remember squared, we're going to try to use these Pythagoreans. Let's see if I can do anything with cosine squared minus 1. So let's take a look at this, see how could I rearrange that, okay? Maybe go back to this one here. What I want is I want cosine squared minus 1. So I need to subtract 1 to both sides of the equation. So now I've got sine squared plus cosine squared minus 1. Then that would equal 0. If I want to know what cosine squared minus 1 is, I need to move the sine squared over to the other side. I need to get cosine squared minus 1 by itself. I need to figure out what does cosine squared minus 1 equal. What can I replace cosine squared minus 1 with? So the sine squared needs to get out of there. So I need to subtract that to the other side. So now I get cosine squared minus 1, and here I get negative sine squared. So I've got sine x times negative sine squared. Sine x times negative sine squared right there, okay? Again, if you need to think of it as other variables here, you can do that. You've got u times negative u squared. that would be negative u cubed, right? So here what we get is negative sine cubed x. All right, there's another way we could have looked at this as well, though. That if you didn't like that too much, let's go back to the beginning. Let's say we looked at this problem at the beginning and we said, well, cosine squared, there's a squared there. Could I use a Pythagorean identity? What could I replace cosine squared with? Let's go back and look at this here. Okay, let's go back to this equation and see if I want to know what does cosine squared equal. What is cosine squared? What could I replace cosine squared with? Well, I'd want to isolate cosine squared. And so if I've got sine squared plus cosine squared is 1, to get cosine squared by itself, I would subtract sine squared. And that would mean cosine squared was 1 minus sine squared. Okay, and technically the way I'm writing this doesn't make any sense at all. You have to have an input for the function, right? There would have to be a theta in all of these. But for rearranging the Pythagoreans, if you want to, just kind of see how it works without writing that variable every time, that's fine. We will do a lot of this rearranging. We're going to take these Pythagoreans and move things around in the equation. All right, so I just figured out that cosine squared is 1 minus sine squared. Let's see how that could help me here. So we're back to the original one. So sine x, and then instead of writing cosine squared, I could write 1 minus sine squared. And I've got minus sine x. Okay, so this is another way to solve the problem here. So this is why some of us actually think these problems are really fun. Some of us really enjoy this, and we're going to have a similar thing tomorrow. They're kind of like puzzles. There's not just one way to do it. There's often multiple ways around it, and it's just kind of how can you play around with the different identities? How can you play around with the different things that to make something happen? It's just kind of a puzzle. Hopefully, some of you might see how these can be kind of fun here as you're doing them. So if I distribute this, I'll have sine x, and then sine times sine squared gives me sine cubed. And then I've got this minus sine x here. Well, then take a look at this. You've got sine minus sine. Those cancel out. And so we get the same thing, negative sine cubed x. Same answer, because math works. Right? So because of the nature of these, that they're kind of like puzzles, that there's not always just one way around it. Often what'll happen is if maybe you try something and it doesn't seem like it's working, just go back to the drawing board, try something else. Or if you try something and it seems like it's just way too ugly, like maybe you could make it work, but it's not. This doesn't seem like it's working great. And just go back and see if you have another idea. They're just puzzles. Play around with them. Try things. See if you can just make something happen. All right, so take a look at this one here. So we've got these negative x's inside. So for sine of negative x is the same thing as negative sine of x. The negative inside can come outside. Okay. Now what about cotangent? So we don't have one of these odd even identities written right here for cotangent. But I mean, the thing is that these are going to be the same for the reciprocal functions. Like we saw here with cosecant of negative x, we ended up having this 1 over negative sine x. That would have been negative cosecant x, right? So cosecant negative x, negative cosecant x. I mean, you can see pretty quickly if you looked at these reciprocal identities here, these will work for the reciprocal. So if sine of negative x is negative sine x, that means that cosecant of negative x is negative cosecant x. Over here, we can say secant of negative x is secant x. And then over here, we can say cotangent of negative x is negative cotangent x. All right, so let's use that last one right here. We'll have negative cotangent x. And then remember, cosine's the weird one. So these other ones, the negative just comes outside. Cosine or secant are the one where the negative just kind of disappears. It doesn't matter. Cosine of negative x, it's exactly the same thing as cosine x. Right, and so then let's take a look at what else we can do. Well, nothing's squared, so I'm not going to use a Pythagorean identity. I don't see any factoring to do right now. Remember the other main thing that we're going to do this a lot, rewrite things in terms of sine and cosine. Switch everything to be sines and cosine. That's going to be a very common thing to do. Right? So this is sine and cosine. It can rewrite cotangent to have sine and cosine in it. Right, so negative sine x, and then plus a negative, that's minus. Cotangent is cosine over sine. And then it's being multiplied by cosine, which is, of course, cosine over 1. Right? And so what we're going to have here, we're going to have negative sine x, and then we're going to have minus cosine squared over sine. Right? Well, this is subtracting a fraction. This is our final guideline that we have here. Whenever we're adding or subtracting fractions, remember what we need is common denominators. I actually have to make common denominators here. Okay? Negative sine x, of course, that's over 1 right there. So if I want to make common denominators, I have to multiply by sine x over sine x. Right? We can't fraction bust because it's not an equation, right? When it's not an equation, we can't get rid of the fractions. We have to actually make the common denominators. So if the denominator here is sine, I want the denominator there to be sine. I've got to multiply by the same thing, numerator and denominator. And so what I get here is negative sine squared over sine, and then minus cosine squared over sine. Okay, so, well, now I've got a common denominator, so now I can put these things together here. I can say negative sine squared minus cosine squared over sine. All right, so now I've got some squareds, so I'm maybe getting close here. Right? I mean, if you wanted to, you could have maybe tried to make this cosine squared back here turn into something else. You could try that, see if that's another way. Again, these are just puzzles. There's different ways to do it. Play around with it. I think you could have done that. Replace that cosine squared with 1 minus sine squared, and that should work too. Or let's take a look here. So negative sine squared minus cosine squared. Well, if sine squared plus cosine squared is 1, then that means that negative sine squared plus negative cosine squared is negative 1. Right? You could also, look at this. You could try factoring out the negative here. If you factor it out a negative, you'd have negative sine squared plus cosine squared. But either way, you're going to get negative 1 right here. So we've got negative 1 over sine of x. And so we're almost done there. Almost done. Just don't stop quite yet here. All right. Negative 1 over sine of x. Well, sine of x in the denominator, 1 over sine of x. Remember, that's cosecant. So we want to say negative cosecant x here. Okay. So the things that we try to get rid of if we can, if we can express our answer not as a fraction, we want to do that. Try to make your answer not be a fraction if that's at all possible. If there's any kind of adding or subtracting in your answer, see if you can simplify it, see if you can get rid of that. If there's multiple functions, like a sine and a cosine, or a tangent and a secant, if there's multiple functions, see if you can find a way around that. All those different things we're trying to get rid of to simplify it down as much as possible. Okay, so why don't you try a couple of these here? Again, these are puzzles. Give them a try. See if you can have some fun with them. Just try something. If the first thing you try doesn't work, try something else. Use the guidelines. Use those identities. Just see if you can make something happen to simplify this down. So you go ahead and give these 2 problems a try here. Right. So here are the answers to check. And notice on the first ones, or the first one here, there's multiple different ways to do it. There could be other ways than the ones I have here as well. Could be other ways for the second one too, but these are kind of a couple common ways that I see people do it, and this tends to be the main way people do this other one here. So on the first one option is just to distribute first of all. Change cosecant to 1 over sine. Those signs cancel out, and then you've got a rearranged Pythagorean right there. Another option that people will do is they'll change the cosecant right away to 1 over sine, and then they've got to make common denominators in there, combine those fractions together, and then you've got that rearranged Pythagorean there, and those signs cancel as well. On number 6, you just have to start out making common denominators. It looks a little bit ugly, but that's really all there is to it. And there's no simpler common denominator. You just have to multiply the first fraction by that denominator over itself, multiply the second fraction by this denominator over itself. And I left it factored for myself because I knew I wanted something to cancel later on. Right? And then we've got, so they weren't next to each other, but that's okay because addition is commutative. Cosine plus cosine squared is the same thing as cosine squared plus cosine. 3 plus 5 is the same thing as 5 plus 3. So reordering it wouldn't be a problem. So sine squared plus cosine squared, that's just 1. And then you've got the 1 plus cosines cancel out there. If you hadn't left your denominator factored, this would be where you needed to factor your denominator. Like if you'd multiplied that out, you would have needed to factor it back out so you could see this cancellation there. And then one thing that people will often miss, make sure you realize that that sign is in the denominator there. Right? When these canceled here, sine was on the bottom of the fraction. It has to stay in the bottom of the fraction. That's 1 over sine. So that's cosecant. All right, one last problem that we will do together here. Let's take a look at this. Let's see. Oh, and there's a typo there. Sorry, that's supposed to be cosine squared right here. Okay, so we got cosine to the 4th minus 2 cosine squared x plus 1. All right. Well, I mean, you could try to use some Pythagoreans right now if you wanted to. You know, this is squared. You could try to play around with some other things. But this one is actually one that we want to factor. This is actually a quadratic in disguise. So we're going to factor this thing here. And if you feel like you can factor it right now, that's awesome. If you feel like you can factor it with just having the cosines in there and just go ahead and do your parentheses and make it work, then go ahead and do that. If not, remember we did that u substitution. Right? So we would say that u equals this middle part right here, because the key is why this works is that cosine to the 4th is cosine squared squared. If this is that squared, then it works. Okay. So if u equals cosine squared, then what we've got is u squared minus, minus 2u plus 1. And so we've got u minus 1 times u minus 1. Okay. And then we would have to put the cosine squared back in there. Now again, if you want to skip that and just try to factor it right away, you could do that. What if we just tried to factor it right away? We would say to get 1, we'd have to have 1 times 1. To get cosine to the 4th, we would want cosine squared times cosine squared. And then this middle term here, we want to be -2 of the cosine squareds. So we want -1 cosine squared and -1 cosine squared. Gives us the -2. Okay? Or do the u substitution. Put your u back in there. And there you go. All right. Well, again, we're just going to do these rearranged Pythagoreans a whole lot. I think we even saw that one before. Yeah. We already did this one here. Cosine squared minus 1 would be negative sine squared. All right, so we've got negative sine squared. And then instead of writing it again, I'll be lazy / efficient and just say squared right there. And so, of course, a negative squared becomes a positive. Squared squared, I get sine to the 4th of x as my final answer.